Hi, your next challenge in the 7 Caillou series is called Count the Divisors of a Number. Count the number of divisors of a positive integer n, which they will pass in to us. Random tests go up to n equals 500,000. So you can check the examples. Notice on the input 4, it should return 3 because the number of divisors of the number 4 are 1, 2, and 4, or you can think of the factors of 4, right, are 1, 2, and 4. You could have 1 times 4 or 2 times 2. And so once you generate this list of factors, you simply return the count of it. And then go ahead and look at the other ones. 5, the only factors are 1 and 5, right? You can't use 2, for example, to evenly divide into 5. You're going to have 2 with a remainder of 1. Same kind of idea. The others, 12 has 1, 2, 3, 4, 6, and 12. 5 wouldn't be, right? So hopefully you can see these are a list of factors and that you're returning the count. So you have enough tools to do this one on your own. So pause the video here, give it a shot, and then resume when you're ready. And I'll get started. So for this one, I'm going to use a simple brute force method to do this. I'm going to loop over the integers from 1 to n. I'm going to check if they evenly divide into n. And if they do, I'm going to increment a count. Otherwise, I'm just going to continue to the next integer and check that one. So to hold my local state, I'll make a variable called num divisors, and we'll initialize that to 0 to start. We don't have anything, and as we find them, we'll increment it. Then I'm going to use a simple for loop. Actually, we're not going to be dividing by 0. That's just a habit, right? Because we normally index things by 0 with for loops. So in this case, I'll start from 1. I is less than or equal to n, right? Notice 4 is included, right? 4 is a factor. And then we will increment I with each loop. So good, we're going to start from 1 and count up to n. And then it's a matter of checking if the number is evenly divisible. And by that we mean when you divide it, there's a 0 remainder. There's not a non-zero remainder. And so you should know an operator for doing that. If n modulo I is 0, right? That means there's no remainder. In that case, we know we've encountered a factor, and we can increment our number of divisors. It will loop through all the way up to n, incrementing this as necessary, and then finally when you're done, we simply have to return num divisors to hold up our end of the method contract, right? It needs to return an integer. I made an integer. And I think this would do it. I'll go ahead and run my tests. Looks good. We'll do the bigger collection. All right, yeah, I'll go ahead and submit. Note, as is usually the case, there are multiple ways to do this. We could have used a link collection, right? We could have generated a range of numbers from 1 to n, and then sort of applied some filtering condition to it. You know, you can use the where link method and then provide the predicate, and it could have filtered out all of the integers that didn't divide evenly into n. You know, and we'll probably encounter that when we submit. I just went with a pretty simple brute force method. There could be more clever ways of doing it, using math tricks. You know, always be on the lookout for that stuff. Figured this brute force solution was fine here. Let's go ahead and submit. We'll collect our points, and then yeah, go through. I mean, that's pretty much what we did, right? Nothing special. Okay, yeah, here's what I was talking about, using link, right? You generate that range of numbers 1 to n. It's essentially the same thing, you know, but it allows you to write everything on one line for you one-liners out there. I think they could have just used where here instead of selecting count, but that's fine. Yeah, here they used where. It's a little condensed there, that's good. And then yeah, same kind of thing going on. Seems like a little more effort than is necessary, but yeah, do your scans, see if there's anything you can learn from other people. And then, whoa, did that guy go up to 500,000? Don't do that. Thought I saw one in here where the dude was looping. Ew. Yeah, okay. Anyways, take the good stuff, leave the bad stuff, and you know where to find me with questions. Otherwise, we'll move on to another one. Thanks.